Welcome to this presentation on the Inflection API. My name is John Brush. I work at the Zurich University of Applied Sciences, and I gave this presentation on the 1st of June 2016 for Comerge. Like most programmers, I am passionate about avoiding redundancy. And one thing that has always bothered me as an application developer is that I often find myself moving data from one structure to another slightly different structure and then back again. In fact, as developers, we spend an enormous amount of time worrying about transformation. Transformation from back-end to front-end, transformation between interfacing systems, and transformation to and from various data formats. Now, the term transformation can mean different things to different people, but for the purposes of this presentation, I want to define it as the act of converting data within a given language from one structure to another. For example, two systems might both define a class person using a slightly different structure. In this case, transformation from person to person prime mainly involves identifying semantically equivalent data, making any necessary adjustments, and then synchronizing. In recent years, there has been a proliferation of frameworks that attempt to simplify the process of transformation. One example from the web domain that you are probably familiar with is Dozer, which is often used to transfer data from a domain model to data transfer objects and vice versa. But while Dozer may reduce the amount of code necessary to perform the transformation, it does not address the issue of syntactically and/or semantically redundant data structures. Now, to illustrate what I mean by redundant data structures, I'd like to run through a few use cases with a concrete example. Imagine an application with a data model consisting of person and address. Let's say that person contains a large number of attributes and that there is an M-to-N bidirectional relationship between these two classes. Note that there is no composition in either direction, meaning that instances of person may exist independent of instances of address and vice versa. Now, to build, for example, a list view of person, you might only need a few basic attributes such as first name, last name, and title, while omitting all other attributes as well as any associated addresses. In another scenario, you might want to provide an edit view for person. In this case, all properties of person should be included as well as references to any associated addresses. However, the contents of the addresses themselves should not be included, as these do not belong to a single person. By the same token, an edit view for address might include all properties of address, as well as any references to persons, but not the properties of person itself. Sometimes there are situations where it is necessary to adapt existing terminology. For example, person might be student, first name, given name, and last name, surname. And finally, there are cases when you want to combine existing properties into something new. For example, combining first name and last name into full name, or you might need to add completely new properties such as nationality. So if we think of the data model as a sports car, then the previous examples would be analogous to different views of that car. Of course, we are all familiar with the concept of views in SQL, UML, and in many other contexts. The novelty of Inflection is that it takes the notion of views and applies it to object-oriented data models. Now, as Java developers, you might be thinking at this point, well, what about interfaces? As much as I like interfaces, there are several issues that impede their being used as views. For starters, they don't really reduce redundancy, since all property accessor signatures have to be fully respecified in each interface. Furthermore, the dependency is the wrong way around. That is to say that classes depend on interfaces, whereas views should really depend on classes. This is important to ensure that new views can be defined on pre-existing and possibly pre-compiled classes. Finally, interfaces cannot introduce new properties that do not yet exist, whereas views should support something akin to SQL's computed columns mechanism. So let's look at how views work in Inflection. In this case, we are defining a view of person, which includes the three properties ID, first name, and last name. The result is a new class, person prime, that functions as a view of the original class. Specifically, instances of person can be cast to person prime and vice versa using a special Inflection casting mechanism. The symbols ID, first name, and last name are called member selectors and refer here to Java Bean properties in person. The symbol person is called a class selector and refers here to the class person. It also serves as the name of the view within the taxonomy. The symbol simple is the taxonomy name and refers to the specific group of views being defined. In this case, the single view person. Taxonomies provide namespaces for sets of related views and ensure that they are unambiguous. So, for example, the person view in simple is distinct from the person view in any other taxonomy. Now, rather than listing members individually, you can use the wildcard operator to select a set of members. For example, here, asterisk name matches the properties first name and last name. The set of selectable members is defined as the set of persons declared members and does not include any inherited members. The wildcard operator may also be applied to class selectors. The set of selectable classes is defined as any implicitly or explicitly imported class. For example, here, my package is the package name declared for the compilation unit and is thus implicitly imported. Assuming that person and address are the only classes defined within my package, then they are the ones that will be selected. It's worth pointing out the behavior of the member selector in this case. When multiple classes are selected, then any member selectors are applied to each and every class. Here the wildcard operator matches anything, so person prime and address prime contain all declared properties of person and address respectively. Had we specified the member selector as something less encompassing, say ID, then person prime and address prime would both contain only the property ID. Views may be redefined any number of times within a given taxonomy. For example, here the first view declaration includes address, which is overridden in the next line. The order of declaration in the compilation unit defines the order of precedence, where later declarations have higher precedence. In addition to including classes and members, it is also possible to exclude them. For example, here address is defined as first including all members and then excluding person. If no modifier is specified, then the default is include. In this example, student, given name, and surname are aliases. Aliases allow you to adapt the terminology of a data model to a particular scenario or use case. Taxonomies may use inheritance to factor shared structure into a common supertaxonomy. For example, here, related person and composite person both share the view person defined in all. As a side note, views are features of taxonomies just like fields and methods are features of classes. This is because taxonomies are actually virtual types that live in the same conceptual space as classes, interfaces, enums, and annotations in Java. Consequently, taxonomies are compiled, loaded, and linked just like Java classes. In addition to selecting from pre-existing properties, views may add new properties by declaring an auxiliary class. Auxiliary classes allow you to introduce new fields and methods for a view. For example, here the properties full name and nationality are defined in person aux. Now, even though person and person aux are two distinct Java classes, they are regarded by Inflection as two parts of a whole. So from the point of view of Inflection, person prime has two compartments, one containing the person definitions and one containing the person aux definitions. Analogously, instances of person prime also have two compartments, one containing the state of person and one containing the state of person aux. As a result, references of type person prime, person, and person aux all point to the same virtual object and may be cast to and from each other at any time. With that in mind, let's look at how person aux could be implemented. The nationality property is implemented by a straightforward getter and setter backed by a field. The full name property, though, is more interesting. Notice how the getter and setter get access to the person instance by using an inflection cast. This effectively allows for one compartment to interact with the other, which in this case allows for full name to be derived from first name and last name. So you might be thinking to yourself at this point, okay, John, I see what you're getting at, and it's all well and good, but... Well, to answer that, I'd like to give you a few stats on a project at the ZHAW that uses Inflection to generate views for front-end interactions. This particular project has a data model consisting of 85 classes with 3,496 lines of code, and 12 auxiliary classes with 579 lines of code. The views for the front-end interactions are defined in 13 taxonomies with a very humble 117 lines of code, and the resulting views consist of a breathtaking 1,087 classes and a staggering 40,397 lines of code. The really impressive stat, though, is the view to taxonomy ratio, which clocks in at 345. In other words, one line of inflection code, in this case, is saving you 345 lines of Java code. Of course, this number is not set in stone and is highly dependent on the number of taxonomies and the complexity of the model, but it does give you a sense of what's possible. Inflection is still a work in progress, and the experience from the ZTAV project taught us several important lessons that will likely shape future development. One thing we realized is that the selection mechanism needs to be substantially expanded. So while selecting classes and members by name is useful, there are a number of other methods that would be equally useful. For example, isAssignableFrom would allow you to select all subclasses of a class, or hasModifier would allow you to select classes according to which modifiers were specified. Furthermore, it should be possible to combine selection methods using Boolean operators. For example, here we are selecting all non-abstract subclasses of my superclass. As a matter of fact, I have come to realize that the selection mechanism is quite similar to aspect-oriented programming's point-cut selectors, so inflection selectors may eventually start evolving more in that direction. Another thing that I've come to realize is that the as operator is really just a special case of syntactic transformation. Other examples might include changing modifiers, filtering existing annotations, adding new annotations, and so on and so forth. It might make sense to introduce a more broadly defined transform clause for these kinds of syntactic transformations. For example, here person is transformed to student and includes any annotations matching my annotation, while first name and last name are made public as well as being renamed. So in wrapping things up, I just want to briefly go over the project status. It's an open source project under the Apache 2.0 license. There are approximately 60 classes with 7,000 lines of code. So far, there's just one developer, which is me. There's very little in the way of tests or documentation. However, I am working on more documentation at this time. And so far it's only been used in one project, although in that project so far it's been quite successful. So that brings us to the end of this presentation. You can contact me at john.brush@zhaw.ch or jebrush@gmail.com. Please be sure to check out this and other projects at liquidmind.ch or check out Inflection directly at github.com/liquidmind/inflection. Thank you very much for your attention.